Alright, so today we're going to be working on a Glaser coupling. The key to this reaction is we're taking two alkynes with acidic SpCHs, and we're going to use copper to couple those two things together. It has a unique glassware setup, so we're going to start off with a round bottom, right? In a clamp flask. We're going to have a stirring hot plate today, so we have plenty of these stirring hot plates, so both stirring and heating, right? We have water in this little dish. We want to heat this to approximately 50 to 60 degrees, so we'll have to monitor that. Probably 2 or 3 at most on your heating dial. In your round bottom, you're obviously going to add everything you need. You're going to have little baby stir bars this week. We need to make sure we don't lose. We're going to use isopropanol as our solvent, 30 mils of that. So we're going to add that into our round bottom. We're going to add in 100 milligrams of copper chloride, our copper source. We're going to add in 20 drops of tetramethyl diamine. We'll add this in the hood. We'll add 20 drops of this in the hood. Once that's all added, we add in our alkyne, about 2 grams of our alkyne, this cyclohexane acetylene. So we'll add 2 grams of this in. That's the last thing we add. Now to build this all up, first thing we do is we take our Glaser adapter and add it here. One thing of note, we have a lot of glassware we're going to add. We want to have a little bit of vacuum grease on our joints, just a little bit. So that means a dab at most. And usually the way to make sure it's on there good is to twist. You'll see it go clear. All right? So just a little bit of vacuum grease goes a long way. Glaser adapter goes on. At this point in our round bottom should be our stir bar, all our reagents. Glaser adapter goes on, that's the U-shaped one. We're using our thermometer adapters with a pasture pipette. So this is specially designed, we'll have these pre-made for you so don't stab ourselves. Open end. We're going to be using a vacuum to pull air down through here into our bubble through our reaction mixture. So we put that here, and we want to make sure, right, the pipette end goes actually into our solution. At this point, now we need to grab another adapter. We're going to grab our 3-way adapter, which has been pre-greased, put that on there. We're going to grab a SEP funnel. A SEP funnel with about 10 mils of isopropanol, extra solvent. Right? As we heat this up, we might start to lose some solvent. If we need to add, we can always add some more solvent in, and just by releasing the valve, and some more will drip down. Right? Next thing we add, now we're going to need our ket clamps. We're going to need 2 blue ket clamps. Our vacuum adapter goes on. So we're going to need a ket clamp this. There it goes. And then finally you need to have a round bottom here at the end. And we're going to ket clamp that as well. Now, to pull air through this, we're going to need our vacuum adapter. We're going to use our black hose, the thick black tubing, and connect that to our whole apparatus. There we go. You might have to back it up, make sure you get things stable here. All right. Then we will turn the aspirator on slowly, and you'll see bubbling through. As you can see, they start to bubble through. That's bringing air, which contains oxygen, which is a reagent that reacts with our copper. What you're going to see initially is a green color. When that color turns blue, the reaction is finished. There's no longer copper 1 around, it's just copper 2, and that's our sign to know it's done. Some more of the chemistry discussion will be in the handout. So when we're done, this is going like here, it's turned blue. We first take off the vacuum tubing. Right, we don't shut the water off, first take the vacuum tubing off. Right. You can deconstruct this. I mean, the easiest thing to do might just be to take it wholeheartedly here out like this. Put that down. Put our SEP funnel down. We're going to take this and rotovap this to remove all the isopropanol. And then what we're going to do, once we remove all the isopropanol, boiling point 82 degrees Celsius on the rotovap, so I'll make sure it's all completely dry. What we're going to do at that point is we're going to take water, 20 mils of water, and we're going to grab a mil of HCl. And you do what you oughta, you add acid to water. So you're going to go over there with about 20 mils, and you're going to add 1 mil of HCl. And you're going to add that to your dried, at this point, once you finish rotovapping, your dried solid, which will be in there. The acid and the water are going to get rid of any copper salts. Right? Like dissolves like. Our product is organic. Our copper salts are obviously inorganic. They'll be soluble in the water. And we'll filter this after adding the HCl. And that will leave our solid product. Now, finally, we'll have some solid product to vacuum filtration, which we've done. The last thing, the last little bit, which is new, we're going to take that same hot plate as before. We're going to take an Erlenmeyer flask with some ethyl acetate. We're going to do something called a recrystallization. We're going to add all of our solid, which we just got from our vacuum filtration, after we've rinsed it with water and acid. So all that should be left is our final product. We're going to take some ethyl acetate, about 20 mils. We're going to heat it up here. And what we want to do is to get all of our solid dissolved in the ethyl acetate. How do you know it's dissolved? You know it's dissolved if it's transparent. You can see through it. Once it's all dissolved, and you might have to add a little bit more ethyl acetate, or you might have to let some of it go away if it dissolves too fast. Once it's all dissolved and it's been heated, right? You've been heating it to go in solution. You take it, you gently, quickly take it off the hot plate and let it sit and slowly cool down, and it'll come out of solution. That's called a recrystallization. Right? And then once that's done, we'll filter that, and we're good to go. And we'll probably run an IR, and we'll also do some TLC analysis as well.